Right, so it's implementation time, is it? All right. Okay then. So what did we do? We left off with this. Okay. I think the final thing here was that we would apply any input at the server time, right? So when we connect, we should be getting the server time, right? Whoopsie. No, extra whoopsie. Didn't we have a readme? Yeah, we do. Right. So on client connect, send current server time, right? How's it going, Rizal? How you doing today? Let's see, where is our connection? On client send server time. So this is server side, and then client side. There's a D in there somewhere, right? There we go. Keep history of all actions. Actions are verified by the server, but that's not relevant to this. It is very warm. I don't think I have much in terms of gun to show off. I'm a very skinny person. Right? Not much to show there. I can flex my finger though. It's pretty good. I'll keep history of all actions and history item contained the server time. It contains the action and it contains a frame number. Does it contain a frame number? Maybe. Cable for OnlyFans? Yeah. Okay, so let's start with the server. Let's start with the connect thing, right? So where is our server? Is that it? The server, where are you? Okay, so it has a, what's the alpha for? I don't think that was ever used, right? However, it shall have a start time, which is an instant. And we're gonna send the milliseconds to anyone who wants it. That's what we're gonna do. Hello, Lavo. Hurtful with that kappa right there, man. I'm very self-conscious about my appearance. Every streamer loves it when you talk about their appearance, so you should make sure to always do that. That's always a bonus. Okay, so when we start the server, which we do on run, this is where we say self to start time is instant now, even though we already said it once. That's how we do it. Is that correct? No, server time. Or is it start time, perhaps? Yeah, it was right there, wasn't it? You got a job? Nice. Good work. Actually, that's what we're gonna do. And we're gonna pass in the server time here. So the server time is the time we will subtract from our local time, right? Is that true? No, we want an instant from server time, right? Wait, how do I think about this? Shit, my tea water. Oof, okay. That was exciting. I completely forgot about my tea water, and here we are. Okay, I was boiling pretty heavily. What was I saying? Okay, so if we send the timestamp of the server, so we will take that and add that to our current time. So on the client, hello, yes, yeah, that's amazing in here. Async for days, man. Server time is a U128. I'll probably do it as U64 though. That's our offset. And that's that. So for our client, when we connect our unreliable stream, no, that's not it. Let's go to main. Let's go to connect. And then we do this, and then we do send input. We should probably say connection dot now we need the bidirectional stream, right? Open by, oh wait, I think that's the right one. So we're gonna do rx dot receive. Actually, it is not, it's a uni. And then what are we reading? accept a unidirectional stream. Right, so we need a buffer. Buffer the bush kangaroo. And we're gonna read the buffer. And how long are we gonna read the buffer for? Until we have what we need. That's what we're doing. We don't need that. We need to do this. Break. Offset plus equals n. Sure. But now we can get the server state here by doing a buffer offset. Then the JSON from slice server state unwrap. Well, in this case, we don't have to unwrap though, but we can do that. What do we send as part of the server state? We shall only worry about the start time now. So the thing that we're actually reading is start time. So U64. There's no server JSON. Well, we'll have to settle for server JSON then. Okay, so server. Da 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 na 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 na. Da da na 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 na. Da 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 na 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 na. Where's my server time? Where is my server time? Handle my connection. That's what we're gonna do. Okay, so my tea's ready. Where is my server? It's somewhere up. That was spectacularly disgusting tea that shan't be had by anyone. So it is in the bin. Okay, what are we doing? We are doing this now. We are going to send the server time. So where's the server time? There we go. So we're accepting a connection. But before we, we accept the connection. Then we need to say connection.openUni. Oh, wait. And that is our right stream. Okay, and then we'll say 30 JSON to vec server time question mark, or do we unwrap that one, right? Okay, so we are sending the time to the player. So we now have start time. And what happens when we connect then? So that gives us no reconnect though, right? La da 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 da. Da 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 da. Ba da da. Okay, so we are creating a game, new server time. Don't nobody look at this crime. Okay. Wow, that thing sucks, but okay. Server time, that's not right. I think that should go on to the client instead. But what is a client? Food happened, and then I got so excited about this that I want to get back into it. Okay, so we're passing in a connection, but that's a copy. That's not really a client. We need to get the server time in here somehow. Okay, how do we get the server time into our world, right? And if we have to reconnect, that's not even, well, that would say server time here. Bah. Blah. Okay. Let's do this. Let's run a server and let's give it a few seconds and let's run this. Okay. I think that has failed. Connect. The first thing we do is we accept a unidirectional socket. Yeah. And then the server. Yeah, we're getting it, but the server doesn't seem to want to send it. So server, we get a new connection. It says new connection. It says new connection, so that's wrong. Make sure that it's done. Could that have been the predicament? Yes, it could. No, it couldn't. Address already in use. What gives? Oh, that's the server. Website. What happened? Yay, it happened. It worked, right? So 807. 50. Okay, right. Okay, so we're good. We're good. So we've read server time. Then we're going to send input or read game data. Okay, then we have to have our input queue. Okay. Our input's gonna take the whatever we send to the server, right? It's our input. But that has to be a little bit more generic, right? So if that's generic require, great. And then we send the input and we build that and the server gets, so what does the input need? Okay, it needs, whatever we send to the server is going to be a server message. Okay, so we need something called a server message, which contains a timestamp, frame number, and a payload. And the payload has to be serializable. Then we don't need to lengthen code anything. We just read until the stream is closed, and that's it. Wow, this is so much easier than UDP or anything, right? It's already in there, right? Okay, and these things can be condensed into singular units as well. I think we have an architecture on our hands, right? Right, let's start by making the outputs and inputs a little bit simpler. Can they work in the same way? Yeah, they can, right? So we are doing something here. This is the handle input. This is the one that we're going to make into whatever we need here. Okay, so we need to accept uni. We need to base this on the input tx, right? So this could be the same thing, right? So we can have a struct that has a connection. It has an input, it has a tx, which is a sender of t. So whatever this is, it is generic over t. What a nice thing. Okay, so let's implement. Okay, we're gonna call this thing guff. All right, so let's impl our guff. Do something. Take ownership of self, will you? Guff. You are async. That's what you are. Welcome. And what are we gonna do? Do we need a buffer on here? Ooh, why don't we have a buffer on here, shall we? And we can make this a little bit too cool for school, right? Now, that's a little bit stupid, right? Because if the buffer is large, then it doesn't really fit on the stack the way it should. But that's okay. This is gonna be for small messages anyway. So, some tiny guff, right? Oh, guff will suffice for now. What do we need? We need to run a loop, run amok with a loop. We need to say self.connection.accept unidirectional something rather, and await that. That is going to give us what we need. We'll match on that. And if the connection is closed, then we're just gonna bail. So let's fill the arms, shall we? Yeah, apparently not. What are you griping about then? Oh, there's no connection. There is now. Right. Now we can fill it. All right, so there's an error. We're just going to log this. and break. Stram. Okay, that's our stream. Now that's our stream. Before it was just a syntax error. So that's our stream. We get the value and then we're going to serial. So this means we need to say where T implements deserialize. But we have to deserialize to owned. Okay. We can't just do a regular because we're going to send this to possibly another thread, right? So we can't just slap this in the middle of some other arbitrary place, right? They don't necessarily live in the same thread is what I'm trying to say. I'm just very tired. All right, then the stream.read. So, oh, I made a mistake in the previous code. I just realized self.buffer, but we have to say while. Oh, okay. This is problematic, right? If we try to read into the buffer, if we try to read into, if the offset is the length of the buffer, then we are goofed, right? We're done. It's not really an issue, but it kind of is an issue. Okay. Here we're done reading, so we break. So if we have exceeded the buffer length, we're trying to send a message larger than the size of our buffer, then we're a bit snookered and we have to figure that out. But don't know what to do there. I mean, we can do things like allocate the buffer on the heap, right? So if we make a new one of these, we can have we need to have a con and RTX. We can allocate the buffer on the heap. Should we do that always? So if we allocate a large buffer, yeah, let's do that. You agree with me? That's great. That means you are just as smart as everyone else, right? Okay. Ah, right. Why would you not? Oh, that's a boxed slice. Then this thing is completely redundant. Goodbye, const annoying generic. Then you were cool, but now you're not. But then we need to have a capacity. So not as nice, but it is something. So we can make a new one and then we can do something, which means exist in a loop and look cool doing it. So once we've done all of this, then set.tx.send, we're going to break with the value. No, we're not. We are not breaking with the value. We are reading the offset into. So set.buffer offset 30 JSON from slice unwrap wee. All right, and then unwrap that too. This cannot unwrap. This one we have to match on, because if the connection closes down, actually this is likely to be the server TX, but if we do this and we say here if let then return, we can log the error as well. Client, no. Sender. There we go. And then what is this thing? This thing is, whoopsie, guff. Well, it is guff. What is this? Read error. Read error. And what is this? Unidirectional stream creation failed. What a long message. And then here we can just call this run. I think that has to be mutable. Yeah, it does. All right, so we can now have a, what do we call you in reality then, right? This is like a map between a connection and something else. So let's just get our guff going. I don't think we're missing anything. Yeah, this thing doesn't even do the byte handling correctly, right? It reads until it's done. But that might not be the right message. This might just be a partial message. So this thing is broken, right? Handle input, more like scandalous imprints. I don't know. Let's spawn, instead of handle input, we'll spawn a guff new with a connection clone input tx and some kind of buffer size. Now we run that. Whoop. Wait, how did I hear that? Oh, it must be my phone. Okay, so we are now able to do our input thing. But this is effectively a map between, so this is like our own channel stuff, right? Which I think we can now move into a net component of Joy. Well, we're going to be a little bit cautious about that, but we can move this into our shared stuff, and that's the stuff that will be eventually moved in there, right? We have our connection, we have our inputs, a little bit gross. Oh, is that kind of input? Oh. Okay, let's make a new module here called net. New source net.rs. That is definitely not the name of it. Okay, so let's have our own channels here, right? How do they work? Because we might not have the connection yet, right? So do we have Flume? We do now. Okay. So what do we need to do this? We have one function that creates a pair of some kind. So that's jerk over t. The output of this is going to be out t and in t, but no cup of tea. And it's this in t that should be able to, okay, so let's have struct out, struct in, and then this in should become a net in by taking this input, right? So the out should just have a sender of t, I think. And in should have a receiver of t. Yeah. Okay, this is going to get a little bit weird now. So let's implement in t. I have a function called connect that takes a reference of self and a connection, which is a connection from this crate, and it gives us a live input, a net in. I don't know if net in is the right thing here. So we'll rename that though, right? Yeah, so there's clearly a mix-up between the sender and the receiver here, okay? So the connection is there. Should we take a reference to a no, we'll clone the connection, it's fine. And then our tx is self.inner.clone. Then this and that swaps this. Okay, panic because you're being annoying. Okay. Almost there. So this is going to be our from the outside coming in, all right? So let's implement our net in, which is a weird name now. That's what we want to do here. Now we want to do all of the server stuff here, right? So let's just grab the server source. I don't even know where it is. It's not here, is it? Guff, where are you? Oh, he's here. Let's just do this. Beautiful. So, wait, that's this pair. Right. No, not right. Cargo at log. There's our frog on the log and the cat and the log and the dog and the log and the cat and the log. All right. There's a cat and a log and a dog and a log and a cat and a dog and a log. Yeah, that makes sense. Okay, so that should not self-return. It should return something else, but we don't know what yet. We need a buffer. So net in needs to have a buffer size. I don't think there's any part of me that's going to be comfortable writing with those fingers so much, but okay. Buffer. Buffer.com. Próxima estación, el buffer. Okay. 30 JSON. No, here we need a where clause, right? Where T is deserialized owned. Again, because of how we have to transfer this data. But that's it. So now we can replace this with a net in instead. So lib net pub net, right? So let's go to our server. We can get rid of Goff now. Mr. Goff. Bye. Okay, so let's start off by doing net, net in. But how do we get the net in? We're not going to do that. We have the server tx, input tx. So that's supposed to be bounded. Then let's make that a thing. Our pair will be a bounded pair instead, and it has to have a capacity. Yes. So let our txrx equals bounded with a capacity, and then out. Get out of here. Out has a receiver. That seems so weird that out has a receiver. But that's because the network's input, all right? That's this connection, this incoming data from here that is written to the sender. So really, it's our output that becomes our input. Ooh, that's even more profoundly stupid. Okay. So out connects, returns a net in. Okay. There we go. Beautiful. Okay. Bounded. Why? Right. So we need to create our input tx and input rx. So that's a bounded pair now from shared. Hello, toasted sandwich. The comments keep coming. I'm loving this. All right, input rx will be, that would be in. Yes. Input rx is now in of shared input. Yes. And that comes from the server net. Ooh. Ooh, biscuits. Okay. Calling it in and out might not be the best. Okay, let's call it RxTX then, because I am old. And that makes sense to me. If it doesn't make sense to you, that's okay. So that will be net RX. Tasty naming right there. Okay. Okay, that is our TX and that's our RX. Then why don't we rename you into TX and you into RX. That's then an RX. Wait, why can't we find RX in here? Because they are not public, that means you cannot have them. Okay, and then we're just going to look at how we use them. So that should become input tx dot what? Dot connect to this with that. That we then run. Magic. Wait, unmagic. Okay. No. Input is now an Rx input. So our inputs is a vec of Rx shared input. Okay, so we're gonna have, we can have receive and receive async. I think that's okay. Actually, we'll treat this as a queue instead. So instead of receive, we're gonna do something else, but that doesn't really matter. That does not matter one bit. Not a sausage. Especially since we're not even gonna use this. So why don't we do something? Okay, we'll comment that out. Easy. Which means we don't have, okay. Shit. Okay. Fine. We'll do that then. Okay, try receive. That'll be self.inner.try receive. And what will you return? A result of T. Oh. Smarty pants, eh? What do we return here? That's supposed to be a try receive error. I guess we can have that. From Flume. Once you flume, you can't gloom. Alright, perfect. Okay, well, that's just working then. Can we go look at our server? Maybe. I don't want to be shared anymore. Alright, and let's go back here. Now here, here, and here. So we are doing our connect somewhere. Handle connection. Here we go. Look at that. So all this code here is replaced with this line here. That's pretty spectacular. What about world updates? So that's world RX. Okay, why don't we have a similar looking thing here then? So we are doing what? World RX connect to the connection. Do we need to clone it? I don't think so. Oh, wait. And that's it. So world updates becomes replaced with something that has an RX instead. Too exciting. Mm-hmm. we do need the connection. We do need the notion of, okay, unbounded pair. And you can go to the top of the file, okay? This is our TX. This is our RX. And this is our net RX. And then we need net TX over here, right? We need a connection. We need a receiver of T. And I think maybe that's all we need. Wait, what are you griping at? Oh, right. So connection. Or maybe we are lazy and we do that. It has happened. TX, no. Yes. RX is self.inner. Okay, so there's no bounded pair. There we go. And then player con has a world TX, but that becomes a TX. All right then, back to connect. That gives a net TX, import T net TXT, pub function run takes async, sorry. Takes a mute reference itself and score. Output's gonna push a world TX. That is not right. It's not a world TX anymore. It's a TX of arc-u8. The arculate. Oh. No method named send. Wow. We shall remedy that one. Is that async? Nope. 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 Okay. TX. Thinking that maybe this is not the right thing to do. No. Hello, Skylar. This is wrong. This is still an RX. No, this is not net TX. This is not RX. This is net input, and then we have net output. And that is, well, that can be T. But T has to be anything that implements as ref for our byte slice. Yeah. So we will loop the loop or lopo if you can't write. And then we'll say self.rx.receive async await. That's our payload. And then we shall say connection dot open unidirectional await match on that. Fix no, okay. Okay, stream. We have to fly without pants now. Stream O. Log error. Whoops. And and then break. I just use Vim for all my authoring. I'm an author now. I'm not. But I use Vim, obviously, or near Vim. But there are writing modes for it if you want, but I never liked any of them. Error opening us Unistream. E. And then stream the right all payload. Crap. You want to make your own for writing. Okay. Well, you don't need line numbers. And question is, are you going to do this in the terminal as a terminal editor, or are you going to do this as a... Oh, hang on. Christopher. I thought you meant writing as in writing books and writing material, but you're talking about sources on writing your own text editor, right? Not writing text editor. Oh, wow, sorry, I'm being particularly acoustic right now. Right, okay, so there are a couple of things to say to that. The biggest focus, at least when you start, is probably on how you're going to store your text, right? There are four ways that you can store text in. One is just a plain string, and that's rubbish. Don't do that. Then you have a gap table. That's what Emacs uses. That's probably the easiest thing to implement that isn't just a string buffer, but it has its shortcomings. If you go a little bit up in skill requirement, you have something called a rope, which is probably what Vim is using. Something, at least Helix is using a rope. So a rope data structure. There is another one, which is what I would use, or what I used when I was poking at this, which is called a slice table? No. Wait, let me find it. So we have a gap table, rope, and what else? New, it's called gap buffers. Piece table, that's the one I was thinking about, right? So these are the ones that are relevant for you, right? Ropes is probably the most difficult to implement. Piece table is probably good enough performance-wise, and definitely what I would do. There is VS Code piece table, a good write-up here. Yes, it does. And this is probably the article. Yes, so if you just skim through this one, it's not too bad. That will teach you how to make a piece table, and it is definitely gonna be fast enough. There are existing rope structures implemented in various languages if you don't want to write your own, but I do believe that the fun to be had would be here, so that's where I would go. Other than that, you just need that and a way to render, right? And you should be off to the races, right? Whee! NetTX, you're net output, aren't you? Output. So this one will write payloads to the connection. There we go. Right. All good. Let me know how it works out. Net input would be receive data over the network, serialize it, and write it to the underlying learn to spell connection. All right, that's the job of the day. Full stop. No. So NetTX became net input, didn't it? Now, here's the thing. I think everything is dependent on RX, okay? So this is connect input, which gives us a net input. And then we have connect output, which gives us a net. Why don't we just call you net input, net output? Easy. That will be an output, which is not gonna do that. Output, where's my connection? There's self connection. Payload is a result for some reason. Match on this thing. If there's an error here, then we can kind of presume that it's closed, right? Fail to receive payload. And then we shall return from whence we came, shutting this thing down. All right, so that is T. Write all takes, right, so as ref. Okay. You have what? No, you dummy. It was the right thing to do. So this one will receive stuff that we write in network. The other one will send the things we got from the input. Okay. So net input actually is, oh my God, I confused myself. It's the lack of T, no doubt, right? No doubt. How's it going, Wixer? How you doing? Okay, then so let's think this through then. So our input needs the receiver. So the RX can only become the output. And the input has to be from here. So, well, apparently I had already written that, but since allegedly my parents are siblings, it has put a bit of a dent in my existence. Okay, so the input TX is now net input. And the world RX is net output. So this one is what? A TX. So we should have a send on our TX then, shall we? I mean, I can't see why not. Pub function send self payload T. Probably a result as a result. Self inner send payload. Now that returns a result of a send error T. And what does that mean? The send error T is there because if we fail to send it, we still get to keep the data we've tried to send, but that is not the one we need. Oh, wait, is that the same guy? 1 second. Oh, boo. No, gross. Go away. You are not wanted here. Why? Okay. Then where's the Dave that was here earlier? It's getting a bit dark. Let's pretend that we have morning sun again. Okay, so we want a send error here. Shall we have a send error here? Like so. Wait, is that the same? It is the same. Import. All right, So that magically works now, and that reduces all the guff that we had. So we can just create these and get rid of a lot of stuff. This, and this. Yes. No chat for you. Yes, we do need the disconnect though, don't we? So that was pretty simple though, wasn't it? Then we need something that is a server message, right? So everything that we write has to have server messages on it. Okay, so let's go back to our shared input. So this thing is going to have a sender server message. No. What are we going to call that? We need it to be something that can be deserialized and serialized. Wait, what? Yes. No D. No D for you. Okay, value is T. So this is what we get from the client, but this needs to contain a timestamp. But does it also contain a frame number? Let's find out. Okay, this one's a little bit tricky. Do we include a frame number? Why? The frame number comes from the client. That is actually rather meaningless. So the timestamp is what the server sees. They're not going to be exact though, are they? Which is a little bit confusing. Confusion indeed. Wow, people are weird, but that's okay. So, for instance, a certain amount of milliseconds will have passed as we send the input, right? So I send the input at 900, but that's what I think is 900. Even though we have the server time, it's still going to be a little bit off, right? It won't be exactly the server time, will it? So we don't have fixed beats then on the server? Well, maybe. Maybe. Now I am unsure. I'm very unsure here. We have a timestamp on our message. Message. Excellent. MSG. Monosodium graphite. All right, so timestamp U64, and then we'll make a new one. So impl message. That will have a value of t, and it will have a timestamp. But I think that something else should make these. Right? So we're not actually making these. Ew, what did I smash? We are not making these here. Instead, they have to be constructed by something else that will attach the timestamp to it. But we can come back to that. Okay, so what does it look like on the client when we send our input? We'll send the input. It will be timestamped from the receiver. From the receiver. This is an trying not to architect a mess here, right? Is it maybe that we send all the inputs to the client? Some frequency of the past. Could that be right? Okay, hang on. Let's think about this for a second. If we have 3 connections and they all tag various messages with some timestamps, and we send these messages to the server will insert these messages into its queue for processing. It can even interpolate with that. But that, no, we're supposed to have fixed time step. How you doing, runtime? Done. Are you done? Okay. Have fun. Okay. Okay. See, I'm thinking about this in 20 millisecond increments, right? So if we are doing this, right? Let's say that we have client 1, 2, and 3. So here's our timeline. Can we do this? Is Vim gonna soil itself if we do this? Well, that was not the right thing to do, was it? Down, 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 thank you. Okay, it did not soil itself. It was rather unsoiled. But then it's gonna look like this, though, innit? Unless we delete all that, innit? Okay. Hello. So this is what the server sees. But then client, can we just move it? There we go, right? So client 1 is gonna have a bunch of weird messages, right? Let's say that this one has messages that look like this. And that can't be. That can be. And that can be. All right. These are the client's timestamps of client 1. And then client 2 has some rather arbitrary messages as well, right? Some arbitrary timestamps. So how does this work? Is this timestamp, does it get shoehorned in here or here? Are they like gaps between? So if every action takes 20 milliseconds, is it going to be 15 and then plus 20 milliseconds, right? Is that how it's done? So when we connect, we get the server's running time that we're going to use to do this. Maybe that's how it goes. So when we send a message timestamp is equal to self.time.runtime elapsed plus server time. So if the server has been running for 10,000 milliseconds and we've been running for 1 millisecond, then it's actually at 10,001 in the history of the server that we performed our action. Okay. What if we, okay, so maybe this is right. Maybe this is right. So this action will run for 20 milliseconds, right? Start and ends at 0015 plus 20, right? Is that how this works? So our server history really looks something like this. It's a little bit painful, but I think we get there. It says nothing. Well, this one starts at 50. Let's make this start at 25 and it ends at 45 then to be. So we do this. Action time is timestamp plus 20 milliseconds or whatever the server wants, right? So this one happens at 25. So at 0.20, nothing here, right? Nothing. 0022. So here, something. This is client 1. Let's say that at 22, we're going to go north. Always go north, right? It's where all the cool stuff is. Client 1 goes north. And then here, this one goes east. So this is what our server history looks like. That could work. So I'm trying to think of where this thing could become like a cheat. So at 40, nothing. At 45, client 1 goes west. Okay. So what does this look like in terms of what the server sends? Well, let's say that the server sends snapshots every 20 milliseconds. It's not going to be every 20 milliseconds, but let's pretend it does, right? Server sends snapshots every n milliseconds. Pretend 20 for now. 0, 0, that is nothing. 20 is nothing. 40, this one will now send. Client 1 goes north, client 2 goes east. $60 will send client 1 goes west. Is this right or not? That is the question. Hello? Family unit? Family unit is lacking ident. It needs to be ejected from the house. Although I think it might be the wife, and she'll probably get super angry if I try to eject her from the house. I'm thinking that maybe this is how it's done, right? So the server, well, the server needs to run a physics calculation. This is true scene. Although I think she might not willingly be ejected. Okay, I'm waiting to see if I'm in trouble or not, if I've forgotten anything. That is a different problem. Okay, if we're going to run a physics simulation on the server, can we do so with this information? So we're supposed to simulate the world for different time steps, right? It becomes a little bit complicated, right? Because we're operating in some kind of imaginary time here, right? There is no, like, we will have a fixed time step for our physics. But let's say that we do our, well, yeah, that's where this gets a little bit complicated, right? Because all of a sudden at 40, so at 0040, we are moving client 1 north for 20 milliseconds. But it's not really at 40 that we're doing that. As a matter of fact, he or it should be done moving at 44. No, sorry, 42, right? So we get the instruction, or we process the instruction at 0040, but by 0040, it should already have been in motion for a long time. Welcome to the Discord, only G. Oh, I'm getting a question. When is dinner? When do you want dinner? This is definitely me getting ejected now. I think that might be the situation, Celestial. Hello, Footlong. How you doing? How you doing, Ology? Oh, thank you for saying something in chat, because I was like, is that a bot? I don't have any real, viewers, chatters, or Discord members. They're all bots. Is that a bot? I'm okay, mate. I'm okay. When the wife is hungry, when the wife is hungry, it's like you better sort it out, man. It doesn't matter how tough you think you are, man. If she's hungry, like, ooh. Okay, but I think this is the issue, right? Or rather, I don't know if this is the issue. I just don't know if this is the correct thing to do. It looks correct, but it also looks very complicated because we have to simulate what the client. We have to start the simulation in the past, right? Well, I mean, maybe not. Maybe not. Soon, very hungry. Okay, yeah, you're not wrong. Maybe maybe can you wait like 10 minutes before I start? Okay, cool. Everyone thinks that you're really scary now. Yeah, I kind of painted a picture where you'll kill me if I don't come and cook dinner. I'm sorry. Well, I mean, you're a harsh wife. You're not. That just came out. That's probably for the best. Anyway, okay. So while I'm slowly digging a larger and larger hole, and someone keeps feeding me rope, okay. Now, is it that when we reach this step, that's when we start the simulation of 20? Damn it! Where's the guy? The guy who reminded me of this. Why Rensky is what I'm thinking. Where's Rensky? I don't have time to talk to Rensky now, but okay. So this was a little bit unceremoniously short, this stream here. I'm sorry. But that's a stream for 0 YouTube viewers. There was like 0 people watching this. And I thought, like, should I bother stream to YouTube? And it's kind of like part 2. It probably would have been more interesting if I would have solved all this and then streamed the solution. All right. You should be sorry, Runtime. I depend on you. You justify my existence on the other platform, right? Inside, my tears are falling. Okay, no. So maybe that's how we do it, right? Let's set a timer. 5 minutes, and then I have to go and cook food, lest I will be causing more grief. Okay. Server gets input from all clients with timestamps. Server processes inputs and update world status. Server sends regular snapshots to all clients. Client sends inputs and simulates their effects locally. Clients get world updates. Syncs predicted state and authoritative state. Interpolates known past states for other entities. From player's point of view, blah, blah, blah. Lag compensation, la, la, la. Right, so we have to go back. Either that or we can start reading the Korean version, right? So in the previous, where the behavior of the server describes pretty simple, it reads client input, updates the game state, and sends it back to the client. When more than one client is connected, though, the main server loop is somewhat different. In this scenario, clients may be sending input simultaneously at a fast pace. Right, updating the game world, every input received from each client, and then broadcasting the game state would consume too much CPU and bandwidth. A better approach is to queue the client inputs as they are received without any processing. Instead, the game world updates periodically at low frequency. The delay between every update in this case is called the time step. In every update loop iteration, all the unprocessed client input is applied, possibly in smaller time increments than the time step, to make physics more predictable. Is this one sentence here trying to answer my rather convoluted question? Possibly in smaller time increments than the time step. And new game state is broadcast to clients. In summary, the game world updates independently of the present amount of client input at a predictable rate. Oh, Rensky. You have like 3 minutes. Damn. Okay. Let me see if I can. Oh, I don't even hear the music, right? Okay. Let me see if I can phrase the question, right? If client 1, so this is 22 millisecond, right? The server time starts. When the client connects, it gets the server time, right? And then it adds that to its own time. But all the numbers we see here, let's pretend this is server time. So this is 22 milliseconds, 40 milliseconds, 45 milliseconds, right? So these are the client 1's input, client 2's input. Maybe ignore that part. All right. So at 0, nothing happens on the server. At 20, nothing happens. At 22, client 1 goes north, client 2 goes east. So this is the command log, right? No, we're not sending that. We're sending, never mind. Go to your room. All right. So 45, client 1 goes west. So on the server, since we have to build the snapshots, right? We have to process these. At 0, there is nothing. At 20, there's nothing. At 40, we grab everything between 20 and 40. So we take the current time and the past time step, and we get all the events that happen there. So 40 includes everything from 20 to 40, right? So here we have client 1 goes north at 22, client 2 goes east at 25. So these 2 events has to be played, right, on the server, simulating physics and the whole thing, right? So my question is, do we simulate everything here? If every action takes 20 milliseconds, do we simulate all of these actions simultaneously? So client 1 goes north at the same time as client 2 go east? Or do we offset this? So the simulation has to simulate from 22 to 42 because it takes 20 milliseconds. It's the simulation. The way I like to design this is the same as you would if you had 2 controllers plugged into local multiplayer. I can tell you right now, there's no way we're going to get through this in 46 seconds. So maybe I should go. Okay, maybe I have to do 3 streams today then, right? I don't know if I have the brain space for it. I'm very excited about this though, but I think this is what I have to do, right? You might be tempted to send me a big wall of text on Discord. I will urge you not to bother because you're wasting your own time. I need to get my head. I'm very got my blinkers on. I can only see this. Set client 1 move in direction to north, client 2 to east, then do what you do in, and that's it. Okay, so you would simulate, you will ignore these timestamps and just say that these belong to this timestamp. Is that it, right? Okay, that answers my question. That was quick. Wow. Sorry, everyone, for very short stream. I'm going to write this down. Okay. So client 1 goes north, and then as a summary, ignore when the client goes north. Just issue goes north for 20 milliseconds and group that with the 0040 timestamp. We can still send back the 022 to the client, right? But include the 0022 when replying to the client, so the client can find the input in the buffer. Okay, wow. Thank you so much for watching. This was a very short stream. It's been lovely. Thank you so much, Rensky, for solving that. That would have been 2 more hours otherwise. You guys have a wonderful evening. I might be back. I might not. Who knows? And with that, I'm going to leave you. Bye for now.